Hello everyone, my name is Shambhavi. Hope you all are doing well. So now basically we're going to learn about the F distribution and the F ratio. So what I'm going to do is that let me just quickly put on the heading, that's the F distribution. So here goes the distribution and here goes the F and here is the ratio. Right? Yes. This is what we are going to learn today regarding the F distribution and the F ratio. Okay. So now let me quickly take out the new color here so that we can proceed on with the basically writing out the things, right? So okay, let's start up. So I will just write out here that the distribution used for the distribution used for the hypothesis used for the hypothesis test is a new one. So yeah, basically for the distribution used for the hypothesis test is new, and for in that basically we have we used out the hypothesis for the distribution. So basically it is called the F distribution. It is called the F distribution. So yeah, the distribution which is used for the hypothesis test is a new one and it is called the F distribution. So right here I mentioned about the F distribution and the F ratio, right? So in that similar case, F distribution is the one which I mentioned out that this is the distribution which is used for the hypothesis test. That is a new one. Okay, great. So here I mentioned of those particular things. So we have the what is that F statistics. So F statistics is a ratio. You could call it as a function as well. So I would just come down here. So I will just mention that particular thing as well. So here goes that the F statistic is a ratio. Okay, so yes, the F statistics is a ratio, right? Now, basically there are two sets of degrees of freedom. Okay, one for the numerator and one for the denominator. So completely I will just mention out that particular thing as well, that there are two sets of degrees of freedom So basically there are two sets of degrees of freedom, one for the numerator, and I would come down, and other for the denominator, Fine. So yeah, here we have the two sets of degrees of freedom. One is for the numerator and the other one is for the denominator. Now let me quickly take out an example here. Okay, so here goes for example. Fine, let's see that what's the example here. So example is that for example, if F follows an F distribution. One second, like this right here. So okay, now basically if F follows an F distribution, so F distribution and the degrees of freedom and the degrees of freedom for the numerator and the degrees of freedom for the numerator are 4. Okay, one second, are 4, and the degrees of freedom and the degrees of, one second, let me just get out some space. So degrees of freedom for the numerator is 4 and the degrees of freedom for the denominator denominator are 10. Okay, so degrees of freedom for the numerator are 4 and the degrees of freedom for the denominator is 10. So in that case we say that, in that particular case we say, then f is approximately equal to capital F, and here goes 4 comma 10. Okay, so yeah, this capital F is approximately equal to this F, and in the downside it comes the numerator comma denominator. So numerator is the 4 and the denominator here we have is the 10, and we just get that out right here. Right, so yeah, this is how this particular has been done. Now here we have some note to be followed out, so let me just go down and let you know that particular thing as well. So here comes the note that we are having out. So the note goes that the F distribution, right here. So the F distribution is derived from the students T distribution, right here goes the distribution. So the F distribution is derived from the students T distribution. Next here we have one-way Anova. One-way Anova. Okay, that's Anova. Right here. So the one-way Anova expands the t-test for comparing more than two groups. One second, let me just go down. So the F distribution is derived from the students T distribution. One-way Anova expands the t-test for comparing more than two groups. Right? Now what's the scope? So I would mention that out, that the scope of the derivation is beyond the level. Right, so yeah, okay, one second, I would just remove this out because the sentence is not to be mentioned out. That I would let you know afterwards. Okay, so let me again take out a color right here. Fine. Right here. So the notice that the F distribution is derived from the student's T distribution, and the one-way Anova expands out the t-test for comparing more than two groups. Okay, here goes the groups as well. For the more than two groups, right? So one-way Anova expands the t-test for comparing more than two groups. Fine. Right. So let me just go above and go ahead with this F distribution and the F ratio. So for the F distribution and F ratio, the distribution used for the hypothesis test is a new one. Okay, it is called the F distribution. Next, okay, one second. Right here. So for example, basically if F follows an F distribution and the degrees of freedom for the numerator are 4 and the degrees of freedom for the denominator are 10. Then in that case we say out that F is approximately equal to capital F, and in the bracket it goes like 4 comma 10. Right, what's the note that we are having? So the note is that particularly the F distribution is derived from the student's T distribution, and the one-way Anova expands the t-test for comparing more than two groups. Right, so hope I am very much clear with both of these statements which I have mentioned up here regarding the F distribution and the F ratio. Now basically we have that how we calculate out the F ratio. We have two estimates of the variance. So that I'll be discussing up in the next video. This is all for this video. Till then, thank you and take care.